So here we go. Review problems for the Unit 3 test. Major tests. I suggest you take it very seriously. You can write down all the formulas and go through all the units. Shouldn't have much problem there. I'll do a few of these. Who has more momentum? Well, before I do anything else, I write down P equals M times V. That's the momentum formula, where M is mass and V is velocity. So, the 4-year-old momentum is mass of the 4-year-old times velocity, and the father momentum is mass of the father times velocity. Well, they both have the same speed, so if that's the same, whoever has the higher mass will have more momentum because they have the same speed. So that's clearly the father. You'll have a lot of problems like this. You need to know how to do them. If you need to put in numbers, you can do that. You could say the speed is 2 meters per second. Who cares? You get to make it up because it's the same. And you can say the mass of the 4-year-old child is 20 kilograms and of the father is 70 kilograms. And you can put those numbers in and actually multiply it out, see what you get. Whatever works. I will leave this to you guys. Here's a great problem to look at. And I gave you some data to work with. I have to climb a hill at the end that's 1 meter high. Let's assume they're moving at 10 meters per second and that they average about 75 kilograms. These sprinters are not small people. Impact takes about 0.20 seconds. So what's their kinetic energy when they finish the race? The energy kinetic is 1/2 mass, 75 kilograms, times their velocity, 10 meters per second, squared. So if I'm not mistaken, that's 375 joules of energy. So how much work does the runner do when going up the 1 meter slope? Well, that's the potential energy. You could also write it as work equals force times distance, and the force they're bringing is the weight, which is mg, and the distance is the height. But as we know, that's just the same as this. So we've got 75 kilograms times 9.8 meters per second squared times 1 meter high. And that would be 735 joules of energy. And I forgot to square this one up above. Try that again. This is 3,750 joules of energy. And they would lose 735 due to work. So how much potential energy they have at the top of the 1 meter slope? Well, that's the same thing. Take the runner and you put them up 1 meter higher. That's the same as potential energy that they've lost or gained, gained by going up. So it's the same thing. 735 joules worth. So they lost no energy to friction or any of the source. What's their total energy at the top of the slope? Well, due to the law of conservation of energy, whatever energy they had down here as they run up the slope, they should have the same energy. It's not lost due to friction. It can't just vanish. And down at the bottom, they had 3,750 joules, and it was all kinetic. Well, up at the top, they're going to have 3,750 joules. And we already calculated that 735 joules of that is potential energy. So they're still going to have 3,750 minus 735, 3,015 joules of kinetic energy. Speed of each run at the top slope should be 9 meters per second. How did I get that? Well, I just plucked it out of thin air. When they hit the wall, they lose all of their momentum. What is their change in momentum? Well, it'd be F times T. But we don't know. T is all the way up at the top. It's 0.20 seconds. So up at the top, they have 75 kilograms. And they have 9 meters per second. Multiply them. They have 675 kilogram meters per second of momentum. So what's the force they feel when they hit the wall? Well, we're back to F times T. Well, we know this, 0.20 seconds. And we just calculated this. It's going to be their change in momentum, which is 75 kilograms times 9 meters per second minus 75 kilograms times 0 meters per second, which cancels. Divide both sides by 0.20 seconds. And we get that the force is equal to 3,375 newtons. Now, that's if we have 0.2 seconds. If this was 0.101 seconds, which would be like hitting a solid wall, doing the same calculation, we would get 67,500 newtons. So hence the wall, because that would be extremely painful to get hit with 67,500 newtons. Not a lot of fun. Now this is more tricky than any problem you'll see on the test, but it's got a lot of the great concept all put together. Change in momentum equals impulse. This is in Newton seconds. This is in kilogram meters per second. You have to understand the difference between the two. You've got kinetic energy. You've got time slowing you down, therefore making a smaller force. Whereas if the time was less, you'd feel a bigger force. These are all good things to learn and to know about. Let's pick one more, the last one. So, playground swing. On the swing, as high as possible. Distance there, 2.5 meters. The rider, do my best to put the kid on here. Got extra long legs. Mass is 35 kilograms. So, what's the two places that they have the highest potential energy? Well, that would be at both ends of the swinging motion. And what would that potential energy be? It's pretty easy. Energy potential is mass times G times the height, 2.5 meters. And that equals 800, and we will round 858 joules of energy. So, where's the kinetic energy the highest? That would be at this point here. We'll call that the middle of the swing path. And the kinetic energy there, well, law of conservation of energy says that the potential energy at the top is equal to the kinetic energy at the bottom. Let's get 858 joules. And what is the velocity at that point? Well, 858 joules. We just said it equals the kinetic energy, 1/2 times 35 kilograms times velocity squared. Multiplied by 2, multiplied by 2, Divide by 35, divide by 35. We get v squared equals 49.0, and we take square root of both sides. V equals 7 meters per second. So if you can get your swing up 2.5 meters off the ground, you'll be moving at 7 meters per second. Now, what is the potential energy at a point 1.25 meters from the lowest point? Well, that's halfway up. So that now we have half of its potential, and that's our total energy, and half of its kinetic. So that if we add them together, we're still going to get 858. So the potential energy is 429 joules, and so is the kinetic energy. That's it. I will post the rest of the answers eventually. Good luck, and let me know if you have any questions.